Hi, I'm Yichen Jiang. Today, the paper I want to present is Deepseek-Prover v2. This is an mathematical proof model that is on arXiv April 30th, 2025. So today I will go through these four parts of the paper: the overview of the task and what they call sub-goal decomposition. That is the main part of their task construct, and also the training details and some performance. So the overall goal is to align LLM reasoning and the formal mathematical proof. For large language model, they use the Deepseek-v2 600 billion version and additional prover, that is 7B, for the large language model and reasoning. For formal mathematical proof, they uses the language called Ling, and this one is having this kind of structure. They will have a theory, and also they will prove starting from by. So in this way, they constructed a proof for theory, and by stacking theories, they will achieve a formal proof. So this is in the paper what they show about their whole task. Let's see here. This is what we usually see in large language models. They do reasoning, they understand problem, they have the sketch, and afterwards they generate a very simplified version of proof structure. And this one is not directly usable for Ling, but very compatible. So here, the have, we can understand it as the define in Python, and the sorry, we can understand it as pass in Python. So in Ling, as long as it don't have syntax error, it can accept it. So afterwards, they did a conversion from this kind of proof structure to the lemma here. So lemma is a more directly usable formal proof. But also you see here, it also contains a sorry or a pass. So afterwards, they will replace the sorry by a correct proof in here. In this way, they complete a mathematical proof. So let's see how the error process goes. This is what they call the sub-goal decomposition. So from the mathematical intuition reasoning, they generated a kind of local draft in order to prove the whole theory. Here I believe they're using a real problem from IMO. So after they have this kind of local draft, they will first become this kind of lemma. So lemma is more usable, more global defined version of theory. And also with this kind of formal theory, a formal structure, they can construct the premises. Premises is defined as like you will have to make the G1 to be true in order to deduct that G2 is true. So this kind of one-by-one process will make the formal proof more structured. So here is their problem setup. Then we will see how they actually train the model. So the first part they do is trying to align the informal reasoning and the proof formalization. They use two methods. They use two phrases of training. First one is the cold start. They uses the large model for reasoning and the prover model for detailed proving things. In this case, they make some data into the corpus for the cold start supervised fine-tuning, and then they have this reasoning-oriented reinforcement learning that gives correct positive signal and give incorrect negative signal. Here, what they try to emphasize also is they want to maintain the kind of lemma structure they introduce this here. So in this case, they keep another reward for this kind of structure. Afterwards, what they do is a kind of expert iteration. This is done by maintaining the best prover policy to have a lot of attempts. In the table, they use this past 8,000 times, so it's like using many attempts. After they have the attempt, they make these successful attempts into structured fine-tuning dataset with the cold start and the structured fine-tuning. They conduct two-stage training. First one is they have a high precision chain of thought version of training. That is, here they uses the chain of thought, and also I believe here they also use this chain of thoughts. They use it to generate a proof structure. This is the structure that the next phrase they will fill in the correct proof. And also they will continue with the expert iteration to fill in the structure a complete proof so that they can have the complete proof. So for reinforcement learning, they uses GRPO, and also in detail they sampled 256 problems, and each problem they have 32 candidate proof to do the training. And the distillation, they uses a very large model. They extend the token to 30,000 tokens, and then they use it to distill 7B model. Let's then see some performance. For the model usage, we can see that using COT, they expand the usage to like nearly 10 times. And here we can see the two versions, non-COT and COT version. They all belongs to the whole proof generation methods. And there are also another class of method called tree search method. So I believe they uses the tree search methods, multicolor tree search or other tree search methods. So they have this kind of scalar after it. And here our model uses the chain of thought that scales the token length. They finally achieve on this dataset for nearly 90% accuracy. So this kind of dataset, it contains many different competitions and many different task types. For example, the algebra number theory, and for this is Olympic competition. This is an exam for the mathematical examination. So in both validation set and test set, they achieved nearly 90% of accuracy. They also tested on undergraduate level mathematical problems in these kind of data sets, and also they did a detailed case study in this data set, and they beat all of the 2025 models, Prover models, like the Godel Prover model, STP, and the Chimia. I believe they are all here, and here their performance. So yeah, in conclusion, they aligned large language model reasoning to the Ling language formal mathematical proof, and they achieve a good mathematical proof performance in the both computational level dataset and also undergraduate level dataset. And they use this and they also use this reinforcement learning. So this is the Deepseek-Prover version 2.